Thanks, Adrian. All right, so I will also have a human component in my talk later. So I want to present our work on a switchable region-based coding tool that we've developed for AV1 codec. All right, so let me start with our motivation. So as probably most of us sitting here know that modern codecs are not very efficient for compress things that are texture-like because of the high frequency content using motion compensations and then 2D transform. So, however, on the other side, from a human perspective, it is often very difficult to see the pixel-wise difference in these type of regions without comparing it to the original sequence. Okay, so the question we're trying to answer is that can we come up with some better ways to represent these regions using approximation, and that gives us the benefit of saving data rate. Okay, so so then our research problem becomes how can we come up with spatial and temporal modelings for these regions while preserving their visual quality. So in this work, we propose a switchable-based texture scheme that are built into the AV1 codec. And we also developed a new perceptual visual metric because, as you can imagine, since we're doing this with approximations, then by comparing the pixel by pixel difference with the traditional type of quality metric may not work very well to evaluate our methods. All right, so I'm going to start with a example. So I'm going to show two video clips from the YouTube UGC dataset where we coded using the AV1 base, and then and then the other with our methods, and just to get a sense of how actually the video looks like, and then we'll talk about their difference in terms of the rate. Okay, so here's a short clip of newscasting video. Okay. Oops. Let me go to this one. All right. So here is the second video. Okay. Anyone notice any difference between the two? Not quite. Okay, maybe if you play back and forth, maybe. All right. So sorry. Okay. So the second video I just showed is actually coded using our switchable texture mode, and then we were able to achieve about 10.88% data rate saving. Now, just to show what are the regions that we are enabling this, so it's basically these trees that are in the background. So this is where we're enabling our texture mode. All right, so let me talk about the basic concepts. So the idea here is that we wanted to first spatially to identify what are these potential regions that we can enable our mode, and both in the current frame we're coding, and then we wanted to find similar regions in the reference frame. Okay, now instead of go through the motion compensations and then 2D transforms, we're going to skip all of that. And instead, we're going to try to use a motion model, okay, to represent this region. And then as we are decoding it, we're going to decode the rest of the pixels in the frame the same as what a codec wants to do, and then except these regions where we'll later on, after we decode the rest of the pixels, to reconstruct these regions, and then this is how the basic concept of our approach works. All right, so here is some of the steps that are involved in our approach. So outside of the codec, we have what's called a texture analyzer, where we're trying to identify what are the regions in a frame that we can consider as perceptually insignificant. Okay, and then we're going to label these as textures, and then they're not strictly texture in the traditional texture sense. So they're texture-like regions that are can be used motion models to represent later on. And then we also, if there are multiple of these regions, want to classify them into different type of classes. So encoder decoder, the same. So in our case, we're using the stable version of AV1 that came out earlier, sometime last year. And at the decoder side, after we decode the rest of pixels, then we use a texture reconstruction to warp these regions from the reference frames to the current frame. So in that sense, no syntax changing is required, and then we're embedding some of these side informations into the big screen when we enable the mode. All right, so in the first part, I'm going to talk about how spatially we can identify these regions. So we actually investigated two type of approaches. So in our previous work, we're trying to more adhere to the codec structure using block-based approaches. And one of the thing that we noticed is that depending on where the blocks are, and then there may be partial overlap with these texture regions, we like to skip the encoding. Then there could be some visual artifacts. So for example, in this Coast Guard sequences, the boat, you'll see that the anchor part of it, and then the part of the head are not very well represented with this block-based approach. So we later on switched to a pixel-leveled texture representation, which are more precise to help overcome some of these challenges we had earlier. So in particular, this pixel level of texture segmentation uses a two-strained cascade network. So you have a stuff string, which are typically these larger texture-like areas, like the grasses, the trees, and so on, that are of our interest. And then you also have the foreground object that are in the object strings. So two of these strings are called sort of extracting the features of these using an encoder decoder structure, and they use shared feature representations. So at the end, you have a scene segmentation, but the part that we're mostly interested in is the stuff segmentation that represents the potential texture regions. So now with this, the 8020 data set, there's a lot of different type of classes that are much fine-grained than we may consider. So we add a step to group some of these classes. So for example, we have the earth and grass. So this is another frame coming from this UGC data set where straight from this scene segmentation, it shows that part of some of these pixels belongs to the earth class and some belongs to the grass. But actually, from coding these regions, we would like to consider as one region because they share a similar motion models. So we were to group them together. And some other example, including the different type of water, mountains, hills, and then tree, and so on. So these are the 4 groups of textures that we're currently considering. And of course, depending on the type of data set that becomes available to us, that we're working on ways to make this into a more expanded type of classes. So next, I want to talk about how we enable the texture mode in Switchable in the AV1. So here is an overview of how this texture mode design at the encoder side. So we have sort of a frame level decision and a block level decision. So at the frame level, we have from our spatial analysis the masks for these regions that we can enable this texture mode. So and then we also then can calculate the motion parameters for these different regions. And we also wanted to make sure that the pixel leveled texture segmentation that fits with the block structure within the frame. So this is down on the frame level. So once we get to a block level decision, we wanted to see whether this is a texture block satisfying that it is completely covered for the entire block is covered with the texture. And then there's some other criteria I'll go into a little more detail later on. And then to decide whether this block should be coded using this texture mode or go through the normal RD optimization. So the texture mode decision basically looks at uses. So currently we're considered the largest connected regions in the frame as the texture class for each of these things, and since this one large region will typically share the same motion information as well, and we're using the global motion coding tool that are available in AV1 to warp textures from this reference frames to the current frames, and then we ensure that the blocks are fully covered by the texture masks for when it's enabled in this texture mode. Okay. So now, as you can imagine, there may be some issues if we just enable this texture mode for every frames that we wanted to code. So from what we observe is that depending on the type of sequences we have and the type of texture mode, and then also depending on the quality we're coding it, sometimes we will not get actually any data rate savings by enabling it throughout the entire sequence. And this is particularly true when we get to the higher QP because of the added set of information that we need to represent the motion information and the flag to indicate whether we need to enable or disable this mode. So there's a desire to enable this when there's anticipated coding gains throughout the sequence. And the other point is, when you have a very small texture area, then the overhead also is bit more expensive to using this. And then also it becomes difficult to have a good motion representation for these regions, and then which can cause some visual artifact. So based on these observations, we propose to use a switchable scheme. So the idea here is that we would turn the mode on and off for each GF group in each of the scene. Okay, and the scene is determined by the keyframes in the AV1 codec, and so we would code it, enable and disable this texture mode to compare the data rate that are used, and also to examine how large the regions are, and if it's too small, then we also would not use this texture mode. And if there indeed is data rate observed, data receiving observed by enabled mode, then we would enable this for the GF group. Okay. All right. So one of the things to evaluate this becomes a bit of a challenge because since we're not doing a pixel by pixel synthesis or reconstruction of these regions, so we need to have some metric that are more tuned to perceptually visualizing these regions. So we propose this quality metric that are based on two previous work by looking at how particularly more focusing on looking at how the texture regions are sort of merges well with the rest of the pixels in the frame, and as well as not causing any temporal issues due to maybe inaccurate representation from the motion vectors, from the motion parameters. Okay, so just to kind of refresh your memory, so this is the video that I showed at the beginning, and I'm using one frames from this video. So one is AV1 reconstructed, and one is reconstructed using our texture mode, and then where the texture mask lies here. So we did this for a couple of sequences, and here's one example. For this particular frame, if we do a PSNR comparison, then so the red line is showing using the AV1 base approach, and then the blue is our text switch mode. That the PSNR is not a good metric to evaluate our methods. So instead, when we use the perceptual quality metrics, we call Qtext, to compare the two, indeed, it aligns much better in terms of the data rate we're observing in terms of the visual qualities. All right, so here are the 4 components of these perceptual quality metric. So the blurry artifact metric, so here we wanted to make sure that as we are warping the regions from the reference frame to this current frame, we're not, it's not causing any, there's no error for the texture areas. And then also we wanted to ensure using the edge artifact metric that there is a good alignment between the texture and the non-texture regions in the frame. And the last 2 are based on the structural texture similarity metric. So here we're trying to do SM-like, but without the point-to-point measurement. And then the last is to measure the similarities between frame temporally. So this is to measure the fluctuations between the frame. Okay, so I'm gonna quickly go through these. So here's the blurring artifact. So here we're looking at the subbands of the six high frequency of the DTC-WT decomposition, and then we do the normalization. And similarly here, for the edges, we're looking at the gradients along the boundaries of the texture non-texture areas. And for the ST-SIM related metric, so here, since it's looking at the cross correlation between the corresponding windows of two image or 2 frames being compared, so we're focusing on 2 statistics of this. One is looking at a mean. So here we're hoping that it shows a high correlation. So we're expecting a larger value for the mean. And while looking at the difference, we're expect that between frames we're seeing a small values for the difference between the ST-SIM2. And then again, we normalize these values. Okay, so to get our Qtext, we combine this just using a linear combination with the different weights right now. So right now we're using a pretty simple threshold to weight the different component, and then of course there are better ways that we can more intelligently assign these values, and then we take this measure into a BD rate. All right, so let's take a look at how this works. So I'm going to show 2 sort of table results. So the first is showing the data rate saving results. So here are some sequences selected from this YouTube UGC dataset. So the green here are indicating that when we turn on the switchable for the texture mode, indeed we're seeing better performance. And the red is where it's actually having less data rate savings compared to when we enable. The greens and red are not turning out very obvious, but they're still you can still see it. So for the red ones are not as well. So we did some digging into see what's causing this, and then part of this is coming from us looking at the first GF group, and then depending on how well these keyframes are being decided, there may be some errors of just looking at the first GF group, and it's not being representative enough for the entire scene. Okay, so that's where mainly this is coming from. So next, we used our Qtext to measure, how well this switch mode works. So this is looking at this. What I'm highlighting here is the yellow part essentially says that we're not, seeing any changes in terms of the BD rate. And this corresponding to the previous table where indeed for these sequences, the texture mode are not being enabled. And for the green one, even though it's showing a positive, I use the green because indeed it was informative from using this perceptual metric, because indeed when we look at some of these video, if you look closely enough, there are small part of this may have some visual effect that the Q-text were able to pick it up. And then for the red one is the only exception that we noticed. So this is a sequence where there is a large lake region. So we feel like this metric may still not be good enough to detect some of these more dynamic-like textures. So that's also something that we're investigating. But in general, I think this is a good way to have a quantitative measure of our approach. All right, so I'm going to show some videos. So this is a different news clip that this is AV1 coded. And then this one is coded using our texture mode. And so this is where the regions were coding using our texture mode. So next is a video for a music video. And this is one where we're using some savings and the oops, sorry, and then the regions. Okay, so here, as you notice that you do have some of these white lines. Okay, so but for this particular sequence, because the camera is very stable, so there's not much motion, so that was okay. But if there's a very rapid change, we expect that there may be some visual artifact that could happen. But again, then we wouldn't be, using detection mode. So here is a sequence. Okay, and let's take a look at so this is the switchable based. Okay, and here is one. So this region here is where we enabled our approach. Okay. All right. So to conclude, we propose a switchable region-based coding tools that can be enabled depending on whether we're anticipating data rate savings, and also a new perceptual quality assessment measure to quantitatively evaluate our approach. So as I've sort of talked about some of these challenges is this may not work very well when we have more complex motion, because right now we're just using a affine type of motion parameters to represent this region, or if we're anticipating a very fast, rapid changing of the motions. And dynamic check texture is still very challenging to model. So in terms of future works, so we're conducting an ongoing subjective quality test. So we hope that this will align well with what we're observing quantitatively as well. And then we feel that there's also opportunities to incorporate, the quality measure in loop in terms of, deciding when to enable or disable this mode. Okay, thank you. Questions?
Time for a couple of quick questions.
Yes.
So how exactly and blame you from the founders? Sure.
Yeah, so for these regions, no residuals or any other motion information except the motion parameters are being sent. So it just directly sort of stitch into this region. So there is no actually any pixel type based synthesis we're doing on the boundaries. But amazingly, it is doing a very good job for these regions. Yeah.
So you apply individual processing between the
No, there's no special processing.
Okay.
Yeah. Yes.
Did you just measure the performance on VMAF?
No, we haven't done that. That's also something that we like to do. But we've, sort of used more PSNR sim type of measures. Yes.
Yeah, so right now there's only a single texture region, right? And that's because you don't want to have any base string change.
Yeah, we can expand this to multiple texture regions as well, but then it will also, involve some indication of how you find the correspondence, right?
I'm wondering, the semantic segmentation was automatically done, like computer vision problem, or if there's a human intervention? I believe it's very hard to do segment perfectly.
Yeah, so as I mentioned that right now there is no human decision involved in detecting these texture regions, so it's purely based on semantic texture segmentation. Yes.
Okay, thank you.
Okay. Thank you
All
very
right,
much.
thank you.
Thanks, Maggie.